Okay, so today we should be on page 2 in your notes packet at the top of the page where it says 2.1 Properties of Matter. We're going to talk about properties of matter obviously first. We're going to move on and talk about our 3 different phases that are involved in chemistry. We'll talk about elements and compounds, physical and chemical changes, then we'll move on to mixtures, and that's all we'll cover for today. So, properties of matter. So when we're talking about properties of matter, the first thing you need to know the difference between is what we call an extensive and an intensive property. An extensive property is a property that depends on the amount of matter in the sample. The 2 best examples for extensive properties are mass and volume. The mass of an object is the amount of matter it takes up, and the volume of an object is the amount of space that it occupies. Obviously, the mass of an object depends on how much you have of it. The more you have of it, the greater the mass is going to be. Also, the more you have that object, the greater the volume is going to be, the more space it's going to take up. Okay, an intensive property is one that does not depend on the matter in the sample. The best example is density. So, just imagine that I had 2 pieces of gold. I had one piece of gold that was the size of a golf ball, and I have one piece of gold that's the size of a bowling ball. Even though those 2 objects are extremely different sizes, their densities are actually going to be the same, the exact same. The density of gold does not change no matter how much you have of that substance. The second example is boiling point. So if I imagine 2 things of water, I have a cup of water and I have a gallon of water. If I were to stick those 2 substances on the stove top and I turn on the stove and I put it at 100 degrees Celsius, those 2 substances are both going to boil at 100 degrees Celsius. Their boiling points don't change, even though I have way more water in one than I do in the other. Okay, about halfway down that page number 2 in the notes we're looking at, there are 3 boxes where it is asking you to draw the 3 different states of matter on a microscopic level. So I'm going to give you kind of examples of all 3. First off, the 3 states of matter that you need to know and understand are solid, liquids, and gases. Solids are very rigid, very tightly compact structures. So if I were to draw the molecules in a solid, they would be very, very close together. Okay, they're going to be very rigid, okay, and very, very close together. Now, if I were to draw clear this really quick. If I were to draw a liquid, okay, a liquid substance is one where the molecules are a little farther spread out. Okay, they're a little more free-flowing, what we call. So these molecules, these little dots, are going to flow in between each other. If we back up and we talk about the solids, those molecules are not going to move around. They're just going to vibrate a little bit, but they will not flow. The last example is our gases. Our gases are extremely spread out, also free-flowing. They're going to move all over. They're going to kind of take this the shape of its container that we keep them in, and those are your 3 states of matter. Now, this is a good time to pause the video. I want you to answer number 2. I want you to take the time to look up the definitions for those 3 kind of key vocab terms: vapor, phase, and solution. Then you can start the video up and we'll talk about elements and compounds. Okay, welcome back. Hopefully you had time to look up those 3 definitions on your own. Now we're going to get into kind of the difference between elements and compounds. So, substances can be classified as elements or compounds. An element is the simplest form of matter and has very unique properties. For instance, I'm going to kind of explain what a element is before we move on to compounds. An element would be any single element from the periodic table, which you should have glued in your composition notebook by now. So if I were to look up, for instance, hydrogen, which is the capital H on the periodic table, it's in the upper left-hand corner. Hydrogen is an element. It's the simplest form of matter, just an element by itself. Oxygen, for example, is another element on the periodic table. It's in the upper right-hand corner. Once again, it's an element. It's the simplest form of matter. It has a very unique properties to anything else on the periodic table. A compound is composed of two or more elements chemically combined in fixed ratios. The best example, and I'm going to kind of piggyback off of what we just talked about, hydrogen and oxygen, those two elements. Those two elements separated are considered elements. They're very unique by themselves. If I were to combine them together and form a substance called H2O, that is what we call a compound. That's water. Okay, once again, if I were to take two elements, form them, put them together in a fixed ratio, H2O, which means I have two hydrogens and one oxygen, that is going to be an example of a compound. Okay, the following chart is actually located on page 3 in your notes. It's a kind of a flow map at the very top of the page. It kind of helps you separate the terminology we've been talking about today. We've gone over everything on the left side of this chart so far. Here in a second, we're going to go over everything on the right-hand side. We're going to go through the difference between our different types of mixtures. Obviously, underneath this flow chart, there are two definitions which I would like you to look up. It's a good time right now to pause the video and look up what physical and chemical changes are. We'll talk a little bit more about these tomorrow when you come to class, the difference between the two. I'll have kind of a flow chart to help you determine the difference between those two types of changes. Okay, we're going to move on to mixtures. So, when two different substances are mixed, they are called a compound. So compounds can be described two different ways. The first one is heterogeneous. So a heterogeneous compound or mixture is a compound that is not uniform or the same throughout. The two examples they give you right here are chicken soup and iced tea. If I were to take one spoonful of chicken soup and I would pour it out and I would take a second spoonful, those two spoonfuls are not going to be the exact same. Unless, obviously, you get extremely lucky. But 9 times out of 10, those two scoops are going to be completely different. Then you have a homogeneous compound or mixture. A homogeneous compound or mixture is going to be uniform throughout. For instance, Kool-Aid or olive oil. Once again, take a spoon. If I were to dip it in Kool-Aid, I take 2 spoonfuls of Kool-Aids out. Those two mixtures or compounds are going to look exactly the same. Same thing with olive oil. Homogeneous mixtures can also be called solutions. We'll get into more solutions this year, but they also call homogeneous mixtures solutions. Okay, I want you to go ahead and on the bottom of page 3, there's a definition about phases at the bottom. I want you to go ahead and cross that definition out in that example. Obviously, I should have taken out the notes before I handed them out, but I don't really like that definition. I think it's going to kind of confuse you when we talk about the difference between our 3 main phases, solid, liquids, and gases. So you'll go ahead and cross out that definition for me. Okay, so that's kind of the end of our podcast for mixtures and compounds. So you should have your notes completely filled out through page 3. Tomorrow when you get to class, I'm going to have a kind of a lab ready for you to go, one that you're not necessarily going to be in the lab for, but it's kind of helping you decipher between things in the scientific inquiry or scientific method. So I'll have that ready to go for you tomorrow. Make sure you bring any questions over anything I've talked about today so that you can ask questions at the beginning of the period and we can get that out of the way before we kind of jump into this lab tomorrow. Hope you guys have a great evening, and we'll see you tomorrow.